This is the end of many of the conveniences that we have come to take for granted. Steel products are discarded into waste streams when their functional life is at an end. However, the scrap can be reused and reinvented as a valuable feedstock through the electric arc furnace steelmaking process. Steel scrap is an important component in the creation of new steel products. What becomes of this material typifies the choices we can make. For if the scrap material heads for a landfill, steel-containing discards would become a huge part of North America's environmental challenge, since they are a large part of the billions of tons of refuse we cast aside every day and try to forget. But when the grapple hook of a steel recycler retrieves this material, it begins a new life. Instead of becoming refuse, this material will join millions of tons of steel-containing scrap metal destined to be reborn into the industrial cycle. Its destination is here at one of North America's modern electric arc furnace steel mills, among the world's largest recycling operations, mills that provide thousands of high-paying, highly skilled manufacturing jobs to workers across the continent. These environmentally safe, internationally competitive plants not only put people to work, they also help to improve North America's environmental performance. Steel is the most recycled material on Earth. Each year, the amount of steel recycled is double that of all other recycled materials combined. That includes all the aluminum and other non-ferrous metals, as well as all of the glass, paper, and plastics recycled combined. Steel is the most widely used metal in the world. It is a key component in most industries, including transportation, construction, industrial equipment, machinery, and appliances. Electric arc furnace producers also provide valuable services to their communities by organizing recycling days, where the public can bring in scrap steel to be recycled by the steelmaking facilities. Steel scrap is available from a wide range of sources, not only from appliances, but also from old automobiles and trucks, farm, office, and industrial equipment, ships, railroad cars, and obsolete buildings and bridges. North American electric arc furnace steel producers recycle, on average, over 14 million junked cars every year, and an equal tonnage from other sources of steel scrap. Steel scrap is sorted and processed into sizes and forms that can be moved about by crane and then put through shredders, shears, and presses to prepare it for melting into new steel products. Shredders can turn a large car into fist-sized pieces of metal in less than a minute. The iron and steel metallic components are magnetically separated from other waste components and become the basic raw material feedstock for electric arc furnaces, making new steel products. Today, roughly 2/3 of the new steel manufactured in the U.S. is made in EAF mini mills from recovered scrap steel. Mini mills use advanced computer technology in the processing of scrap metal. The computer plays a role in selecting scrap that will be melted into the mini mill's electric arc furnace. EAF steel mill personnel ensure that the right amount and composition of raw materials enters the electric furnace. The newest electric arc melting furnaces are high-powered with low energy consumption. Electric furnace capacities range in size from 30 to 400 tons. The inside of the furnace is lined with refractory material, ceramic bricks that can withstand the intense heat of melting steel. After the scrap is loaded into the furnace, the melting and refining process begins. Graphite electrodes are lowered into the furnace, and an electric current passes from the electrodes to the steel, forming an arc. The electrodes don't actually touch the steel, but facilitate an electrochemical reaction, speeding up the electrons in the scrap. This converts the scrap into a liquid state. With the introduction of electricity to the furnace, the scrap steel will start to melt, beginning the process of production of a new steel product. Melting is controlled through highly sophisticated computer systems. Workers in electric furnace steel plants are highly trained in the use of the computerized equipment. Steel mills comply with all environmental standards for air emissions and effluent discharges by using state-of-the-art air emission controls and approved water treatment technologies. Electric arc furnace steel producers are among the most regulated, basic industry sectors in North America and are routinely recognized for their beneficial environmental contributions to their surrounding communities. Once the steel scrap is melted in an electric furnace at temperatures of 3,000 degrees Fahrenheit, the resulting liquid steel is tapped from the furnace. Impurities rise to the top of the molten steel and are poured off into an open pit or a special car under the furnace. This material is known as slag, and when cooled and treated, it becomes a valuable co-product of the steelmaking process. Resembling natural aggregate, it is used to pave roads, highways, airport runways, and support railroad beds, among other applications. Molten steel is sent to ladle furnace stations for additional alloying and refining. Ladle furnaces optimize energy use and assure continuity of operation of the continuous caster. After achieving the optimum casting temperature and alloy desired, the liquid steel then moves from the ladle station into a tundish, a holding reservoir which feeds a steady flow of the hot metal at the desired temperature to the continuous caster. Computers control the speed of the 2,860 degree Fahrenheit molten steel as it enters molds to form cast billets, blooms, or slabs. Continuous casters operate with intensive water cooling systems, allowing fast casting of billets and slabs for continuous hot rolling into bar and structural products, as well as plate and sheet. Continuous casting and other process improvements allow many mills to add greatly to recycling efficiency and have dramatically reduced the time it takes to make new steel. More efficient recycling improves the environment. The use of scrap instead of iron ore reduces mining wastes by 97%, air pollution by 86%, and water pollution by 76%. For every ton of steel recycled, 2,500 pounds of iron ore, 1,400 pounds of coal, and 120 pounds of limestone are saved, also improving the environment. After the new steel is cast, it is rolled. Rolling mill operations are completely computer-controlled and include automatic shape and thickness measurement devices. The billets or slabs are routed to the rolling mill, where they are either reheated in gas-fueled furnaces to more than 2,000 degrees Fahrenheit before rolling, or sent directly through a series of high-speed, computer-controlled rolling mill stands to be rolled into final mill products. These products are shipped across the North American continent and around the world as new, useful steel. Electric furnace mills produce all of the concrete reinforcing bar used in construction and almost all of the structural steel used in bridges and buildings. The steel in the steel-belted tires of your car was probably made in an electric furnace from wire rod produced in a mini mill. Railroad rails, merchant bars, special shapes, pipes and tubes, and increasingly high tonnages of steel plate and sheet are now being produced in electric furnace mills. Steel is at the core of the green economy in which economic growth and environmental responsibility work hand in hand. More than 60,000 men and women have high-paying jobs in electric furnace steel mills based on their ability to turn steel scrap discards into brand new steel products. Safety is the #1 priority for these facilities, ensuring that the production of steel is safe and efficient for employees at all times, with a commitment to an injury-free workplace. The North American steel industry and its major supplier industries provide some of the most desirable jobs in the North American economies, while also creating sought-after jobs in other industries. Every 100 jobs created in the primary steelmaking industry produces 437 additional jobs in support industries, such as transportation and construction. High amounts of energy are saved by recycling steel scrap. On average, making steel from scrap is 4 to 5 times more energy efficient than making steel from virgin iron ore. Electric furnace steel production is at least 10 times more energy efficient than aluminum production. By recycling scrap steel, the electric arc furnace steel industry saves more than 6 trillion BTUs each year, enough energy to power 18 million households, or the entire city of Los Angeles, for 8 full years. North American EAF steel producers also provide an environmental benefit through reduced greenhouse gas emissions. EAF steel production uses almost 100% recycled material as feedstock for new steel production, which results in a reduction of 65% in greenhouse gases when compared to steel production via the integrated process. $2 billion are saved each year in solid waste disposal costs through the recycling of more than 59 million metric tons of ferrous scrap. That's 118 billion pounds of scrap metal. The 35 North American steel companies that comprise the Steel Manufacturers Association operate over 130 steel plants. Most are electric furnace steel producers. They are good neighbors, concerned employers, and dedicated to the protection of the environment. They are ready to take discarded refrigerators, old cars and trucks, rail cars and tracks, farm machines, demolished buildings and bridges, and turn them into new products that will rebuild North America's aging infrastructure, creating new appliances, roads, buildings, bridges, automobiles, buses, railroads, and mass transit systems, as well as an endless number of other new steel products. A dynamic, rapidly expanding sector of the steel industry, they make high-quality, low-cost steel products in efficient plants across North America.